This is the pole input section for mast arms. For this, you just go in and enter all the information for the pole first before it will give you the option to add arms, mast arms, luminaire arms, and things like that. So pick your pole height. For this example, we'll say 23 feet. Ground elevation at the pole, we'll just say it's at 0 feet, and we'll say the pedestal, which is the drilled shaft portion, how far that's sticking up above the ground. Let's say that sticks up a foot. This pole is steel. Most of mast arms, almost all mast arms are steel. Once you hit save, the option will be brought up to attach and add things to this pole. Pole attachments are things that are specifically attached to the vertical pole. If you wanted to, these things are typically pedestrian signals and the like. So we'll put one at 15 feet. To get your attachment angles or attachment alignment, you need to look at these diagrams and graphics. And here, this is a compass to help you determine where on a pole the different degrees are. And this is also trying to help you. And then this will fill in with arms and things like that. These are all designed to help you place things in the proper position. For this one, I'll place the pedestrian signal at 90 degrees. It shows up on this pole at 15 feet tall, which is scaled to how this is 23 feet tall. If this had a luminaire arm, you would add those here. The luminaire arm and the mast arm sections are the same. For this example, I will work in the mast arm section. For the mast arm, I'm going to say we have a 30-foot long mast arm. I'm going to say we attached it at 20 feet above the ground on the pole. For the arm alignment, I'm just going to say that it goes out at 0 degrees, so it'll go out this direction. And then for the rise, I'm going to say it has a 3-degree rise, which is this angle here between horizontal and how far it's going up. You add that, and that creates the pole. The images will update, and this will show you, help show you where the arm is in relation to the compass. To be able to add things onto the arm, you have to first highlight the arm. This activates the attachment list section. If I want to add a signal, a 3-section type, 10 feet out on the pole, and I want the ground elevation, you enter these two fields to help with geometry and making sure that the signal is the proper distance above the ground. This is similar to the attachment height calculator if you've looked at that tutorial. Here's a diagram of what we're talking about. This ground elevation is going to be this elevation right here directly below the signal you're entering. For this purpose, I am going to say that is at 0 feet. You'll want to make sure that this info up here and this info down here correspond to each other on a relative basis. So it doesn't really matter what elevations you put in. If you put 500 down here, then you would need to make sure this is 501. Or 500 if it's the same elevation. For mine, I said this was 0 feet, and I said this was also 0 feet. So I'm saying this is level all the way across. The offset height, if you have any offset, I'm going to say 0, which means that the signal is attached directly, the center of it is attached directly to the arm. If you wanted to move the signal up or down, as they have the ability to do in the field, that would be where you enter it here. A plus would be moving it up, a minus would be moving it down. So I add that, And once that's added, you will see a table pop up down here to let you know if the information you've entered is correct, and it follows along with the geometric standards. It'll also update this drawing here and show where I've put my attachment. What this information tells me is that I have a range of where the arm can be that this signal will work between 18 and 19.75 feet. And then it tells me if it is above the ground, if it meets the minimum requirements and the maximum requirements. It is telling me that it's not meeting the maximum requirements. The reason for that is I violate this 19.75. My arm height is at 20 feet, which is above 19.75, which means my signal that I've input here is too high. So in order to change that, I can either change the offset, and I can move this signal down, oops, I added that. I meant to update, but I will just delete the other one. So what I did there was I moved the signal down 6 inches. Moving it down 6 inches allowed me a greater, it changed the range that I could have this arm in. It moved everything down 6 inches. So now I'm true and true because my arm height and effectively my signal fall within the 17, the bottom of the signal fall within the 17 to 19 foot code requirement. So whenever you're playing with your geometry and you get falses, this just means that you're either above or below the 17 to 19 feet. If you have multiple signals, which we'll just do that here for an example, let's say I add another signal at 20 feet out. The ground elevation is still 0, and this is 0. Also remember that the rise is 3 degrees, so this is going to be slightly different at 20 feet than it was at 10. If I add it, again, it did not work because of the same reason as last time. So for this one, let's just say I don't want to change the offset and I want to just force the arm to be in the right spot. What I can do is I can change the arm height, and I can see that for both those signals to work, if I changed my arm height to 19 feet, everything would work. So I can go up here, change the height to 19 feet, update, and then everything works down here because now my arm height falls between all of these ranges. This is just something you have to play with to get everything to work. It's for your use to be able to make sure everything works geometrically.